Okay, this lesson is on perimeter and area of composite shapes. So what are composite shapes? They're all around you actually. And so they're regular shapes that are simply combined. So if we take a look at this over here, we see shape here, we see here, 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 this figure. And if you ever took art classes before starting a drawing, you try and figure out all the different shapes that make up one figure. So several regular shapes that are combined are your composite figures. Okay, so a common example could be a traffic cone. If you think about a traffic cone, it's made up of the cone piece and the rectangular prism piece. So collectively, this is called the composite figure. Okay, so there are two things to consider, total area and total perimeter. You kind of looked at this in the vertical classroom yesterday. So the total area, okay, refers to the space contained within the shape. So the total area is considering the space inside of the shape, whereas the total perimeter, okay, considers the area, or not the area, the distance outside of the shape, okay? So just a point to add on to that, if you have, say, a composite figure, so I was trying to make these two connect. I can't, oh, there it is. All right, so if you're thinking of a composite figure and you want the total area, you would figure out the area of the square, and then you would figure out the area of the right triangle, and you would be able to add them. So that's what that means, add or subtract the individual pieces for the total. And the same idea with the total perimeter, okay? If you had another shape or same shape kind of connected to that, the total area, move this, the total, the total perimeter would be this whole distance, but excluding that part, right? The total perimeter would be here, plus here, plus here, 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 and here. So do not include sides that are contained inside the figure. Oops. So if you want the total perimeter, do not include that, okay? So let's take a look at the first example, and you might want to take a look at your pink sheet that I gave you yesterday. When we take a look at this, we see that it's made up of two shapes. So we see a semicircle here, and we see a rectangle here. So how are we going to find both the area and the perimeter of the composite figure? So that means the whole thing. It's referring to the entire thing. So let's think about this as two different pieces. We'll think about this as the number 1 for the rectangle and 2 for the semicircle. Okay, let's work with the area first. So if we're considering the area of the first figure from above, if you look on your pink sheet, you'll notice that it's equal to length times width. So that would simply be 10 times 3, which gives us 30 centimeters, and we know that that's going to be squared. And the area of the second shape, if you look on your pink sheet, the formula is pi r squared, where r is the radius. But that's for a circle, so we would have to take that and divide it by 2, since we're only looking at half of the circle. Now, if you look into your calculator or punch pi, you'll see that it's 3.14. How are we going to get the r? So r, if this is the center of that circle, would be this distance here, right? Oops, sorry. And since we know from the other side that the diagonal here is 3, right? That tells us that R is going to be 1.5 squared, and then all of that divided by 2. All right, so the area of the second shape we were looking at turned out to be the 7.065 divided by 2. So the total for A2 is 3.5 centimeters squared. But then to find the total area, remember we have to add area 1 and area 2. Okay, so that gives us a total of 33.5. All right, so the second part of the question asks for the perimeter. And just as a reminder, remember we're not going to count this here, this perimeter, the dotted line. We are interested in the perimeter around here, right? And this perimeter here, not the dotted line. So we have length there, we have length here, and then we have width, and then we have the circumference of our semicircle. Circumference just means the perimeter of a circle, okay? So to calculate our P1, we'll call this section our P1, we'll call this section our P2. To calculate our P1, okay, we know that it's going to be the length plus the width, right? And that adds up to 10 plus 3, giving us a total of 23 centimeters. In the case of the circle, I'm going to say C for circumference, okay, of that second shape instead of the P2. I'm going to say C because it's actually circumference. And if you look on your pink sheet, you will notice that the formula is pi d, d being the radius. Not the radius, the diameter across. And then because it's a semicircle, we're going to divide all of that by 2 once again. Okay? So plugging everything into our calculator, that's pi, the d is 3, and then all of this, right, divided by 2 would give us 9.42 divided by 2, and then finally 4.7 centimeters. So what is going to be our next step in calculating the total perimeter? So we're going to have to add the P1 plus the C2, okay, and that means 23 plus 4.7, so 27.7 centimeters. Okay, looking at the next example, I want you to think about how we can divide this into smaller shapes that we're going to add up. So we see a square over here. We see a rectangle over here. And we have our triangle over here. So perhaps it would make sense to call this 1, call this 2, and call this 3. Okay, let's start with area again. Okay, we're going to work out the area. And if you wish, you can pause this and try and work out the area on your own, and then come back and just check your work. Okay, so hopefully you were able to calculate an area of 91 meters squared. I think everything is straightforward, except perhaps how we got this 6. So 6 being the width of the rectangle. Well, if we know that this is here 2 meters, right? And we are told that this and this are equal to these lengths, then we know this is 2 meters, and we know this is 2 meters. So that tells us that the width is 6 meters. For the triangle, you're given the height as 5, and you're given the base as 6. So using the formula is pretty straightforward. So that's how we calculate the area. Okay, let's take a look at how we would calculate the perimeter now. Okay, sorry about that. Mr. Douglas just interrupted me. If we're thinking about perimeter, we're thinking about the total distance around our composite figure. So we know this distance, we know this, we know this, we know this, we know this, okay? And we know the height of the triangle, right? We know that if this is going to be a right angle, the height is going to be 5 meters. But we don't know this over here. So that should tell you something about the Pythagorean theorem. And so we're going to take a look at that because we know this distance, this whole thing is 6 meters, okay? And if this is going in from the vertex hitting the median at a right angle, this is going to be 3 meters and this is going to be 3 meters. So we have the base, we have a squared, we have the b squared, so we can hopefully solve for the c. Okay, let's take a look at this. Okay, so P1, we'll make this our P1, okay, is simply this 2 meter, 2 meter, and 2 meter. So that perimeter is 3 times the 2 meters, which is 6 meters, okay? Our P2, okay, if we think of our P2 now, what do we have to consider? So let's highlight what makes our P2. This makes our P2, this makes our P2, this over here, and this over here, okay? Sorry, that should extend all the way there, okay? And so if you think about that, we have 2 times 12, right? Plus 2 times 2. 12, 12, 2, and 2. So that adds up to 24 plus 4, which equals 28 meters. Okay, lastly, I did solve for side C. Okay, and I'll go back down here. That would be this over here. So, oops. Oh dear. I'm going to have to draw that all over again. So we had something like this. Okay, right angle. So this is going to be 3. Okay, and the height was 5. Okay, so you're thinking of A, B, and this is your side C. So using the Pythagorean theorem, check to see if C turns out to be 5.8. If I skip to it, pause the video and try it on your own. And so the perimeter for our last section is going to be 5.8 times 2 because there's one here and one here, right? They're the same area, and so those are the same distances. So that turns out to be 11.6 meters. So just to complete the question, the total is going to be P1 plus P2 plus P3, and that turns out to be 45.6 meters. Okay, I want to pause the video and try and do the example 2 completely by yourself. I'm going to put up the answer, but I'm not really going to go through explaining it because I'm pretty sure you're all going to get the final answer, at least make sense of it after you take a look at the solution. So pause the video and check your answer after. All right, so here it is. Hopefully you thought of finding the area of the entire thing and then subtracting one area from the other in order to get your final answer. So the final answer is 34.24. See you tomorrow.